And good evening, everybody. Hey, Petty Berksman, welcome on in. Yes, this is a very strange time for a Digital Dragon stream on a Saturday. Welcome on in. We did not stream this morning because this morning me and Miss Dragon went and attended the Echovate 3D grand opening of their new facility. Great time had by all. Talked to a lot of people, and I think we've got the groundworks in place to actually start setting up like a monthly maker meetup at Echovate 3D here in Raleigh, North Carolina. So we're going to start trying to promote that and get it out there. We're going to start trying to do like one Saturday a month, and we're going to rotate between a morning session one month and then an evening session the next month. That way we can try and get the max participation uh, as we Yeah, a little bit of a weird setup today. Kind of doing things a little bit backwards. Normally we do stuff in the morning and then we go out and do things out and about town. Today we did things out and about town and now we're going to stream. Hey, Jedi Spidey, how's it going? Yes, Jedi Spidey and me talked a little bit earlier today over at Echovate down in Raleigh. Hey, Eagle the Dragon, how are you doing? Um, Mrs. Dragon is doing okay. She's downstairs. Feel free to give her a call and chat with her buddy. Um, but yeah, I hope everybody's doing well. Like I said, we had a great day. I from the moment we got there, I was talking about this Optimus P1 printer, and I don't know. It was like everybody's asking me like, well, why is this? Why is your printer here? And I was like, well, it's not my printer; it's their printer. They've just been kind enough to let me work on it. You literally just walked through the door, finally made it home. Yeah, we left. Like I was trying to get Mrs. Dragon out of there. I figured, okay, about 3 o'clock. We've been here almost 4 hours. Let's go ahead and get out of here. We left about 4, um, because every time I looked up, she was over there, basically selling Polymaker Cookie Cat, helping people find colors, talking about different filaments and everything. She was having a blast. But we got home, walked through the door, and ate something. I took a nap while I was listening to Free Heathen, and then woke up and was like, okay, let's stream. Let's get some work done. Um, a couple of the things that I was waiting on came in today, and now I have a different problem. So that problem is I ordered some 12 station terminal blocks. If I can get the package open. So these are the 12 station terminal blocks. They're a little bit bigger than the terminal blocks that were being used. So I'm now going to need to take a look and see if I can make these work or if I'm going to have to get different terminal blocks to make this wiring work. Now the plan was to use these for the 24-volt side. These particular terminal blocks came with the fork connectors. You can basically put this on one complete side and turn this into a bus bar. We can bring the negative in on one side and add all the other negatives on. Do the same thing on the other one with the positive or red bus bar and bring all of our positives in. And then that way we have all of our connections are made and everything's good. But the problem is these are going to be too big and too long to fit directly on the standoff. So my option could be just put VHB tape on the bottom of these, stick them in there, and let me bring us over. Hello. Give me 1 second. This camera. So rather than mount these on the standoff, what I can do is take this and mount it down right between the standoffs. And that should be fine. I'll just have to be cognizant of mounting any or screwing anything down right next to those standoffs. But I should be able to use these as the positive and negative side of the 24 volt. Then what I did was printed off some of our standard DIN clips here that I can put some Wago connectors in. And that way I can mount those for the 110 side here, right here, and do them side by side. And we can bring one connection in and then the other connection into the other set, and we can get these mounted up and get them going. That's kind of my thought. The other thought process is something we could do is just take this bus or this DIN rail, move it over some, and we can do our 2 110s and then do some do a couple of 2-spot Wago holders. Just print out different ones, and we can do all of our 24 volt on some of these. Maybe print them out in a different color. So that's another option we have, and I can hold on these bus bars or terminal blocks and use them for a different project. But I think what I'm going to do is start with working on the mains power side, get that going, and that way it can give me a little bit of time to think and ponder what I want to do for the 24 volt side, since those are a little bit too big, because I really want to try and get this wrapped up. Everybody was really interested in the Optimus P1, so that was really, really cool. Okay, so this was the connections from 110 to the power supply. So how are you doing today, Petty Ruxpin? And all I'm trying to do is keep these connections somewhat a little bit in place, and so I can keep an eye on what's where. The downside is I'll wind up, if I do the Wagos, I'll wind up cutting off a bunch of port connectors, but that's not that big of a deal. That's not that big of a deal. I don't like EPACs and Cookie CAD at a PC shop. Is that there in Fayetteville? Jedi Spidey? Yeah? Okay, cool. I kind of like that thought. Let me grab my Wagos. We're going to be using the 5-ways. I'm glad we're starting to see more people that are carrying some of these filaments too, because a lot of times we wind up with, like the only place you can get Cookie CAD is an online place. and it's just not as easy to get hold of stuff. There we go. Now we'll run line, neutral, ground, ground, neutral, line into these, and we'll be able to set these up in such a way that we get, so they had, remember we have two 110 lines coming in. The one line is coming in and running the chamber heater, and then it was running the chamber heater and the bed. Is that right? Yeah. So this line that was coming in was running the bed and the chamber heater. And then I should say the chamber heater controller. And then the second line was running the chamber heater and the thermistor itself. So you got to remember that. So this particular connection, I will mount up the connections for the outlet that's currently in there. We'll make sure that we'll have enough of our Wago stuff stripped here. That camera is not the best. Does the overhead? Yeah, because I'm kind of working right here with the Wagos that I'm putting in place here. Now we need about 11 millimeters of exposed wire to work this the best. Now, Wagos are made to be used with bare wire. We can put ferrules on them, but I have found with these thicker wires, it's just as easy to use the plain wires than to try and put a Wago connector, because on the Wago connector, it has to get into the plastic that kind of goes around the insulation piece here. And using a larger gauge like this, it doesn't really work that well. So once again, we're going to do line at the top, neutral at the bottom. And as I think about this, let me grab the label maker, and we'll label these. That way we go back and get our, we keep with our labeling of our connections to make sure that people can more easily define and understand where the wires are going. Yeah, Jedi Spidey. Me and Mrs. Dragon thought those two kids that I was talking to throughout the day, we thought that they like know each other for a while and everything. And apparently, no, that was the first time they'd ever met, was there at the store. That was kind of neat. So this is going to be $110 to bed. Okay, so that's the 110 to bed. This is the bed SSR. This is the um, neutral to bed SSR. They can get their bamboo and polymaker stock in as well. I'm all over that store. The local PC store there or Echovate because um yeah, the stuff with Echovate as far as like their bamboo inventory, in talking with Beverly, I think part of the problem is there's a B2B importer of the local shop there. Yeah. So they may be under the same thing. There's a B2B importer that has gotten a bunch of pre-tariff machines and pre-tariff machines and filament in, and they're basically, I don't want to say hoarding, but they're holding the stock and not shipping it to local stores, even if they had prior orders, trying to get everybody to pay the plus tariffed fees after since, but they've already been imported, so the tariff fees wouldn't apply at this point. It would only be on new imports, not on existing imports. So there's a lot of stuff going on there. All right. I feel like this wire might be a tiny bit thicker than the rest. Labels aren't going to slide on. Seriously? Well, what kind of messed up stuff is that? Hmm. All right, well, that ain't going to work. Yeah, there's just some people that are pulling shenanigans and playing the uh, fee game. And the way I'm going to do this is to a bed, and so I'm going to try and put the neutrals that go to the bed in the same line as the positives that are going to the bed, and kind of do that type of thing. Um, and positive that goes up there. This is the like having a feeling that this is 16 gauge and some of the rest is 18 gauge, and that might be why I can't get my things over this. Or I'll take that back. This might be 14 gauge wire. I might have made this a little bit too. Trying out filament cells to see what sells and what doesn't. Yeah, that's a good idea. Goes there, this neutral one that goes over there. Okay. Prowess. Yeah, 15-minute drive is definitely a whole lot better. Um, so I can understand and get behind that. There's those two. Bum, 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 bum. Ba-da, ba-da, ba, ba-da, ba, ba, ba. It was on this. We'll loosen this, pull this wire in some. We'll make our connections for our ground, neutral, and live. And we'll cinch that back down to give us our strain relief. But yeah, it was definitely an enjoyable day. All right, so the white is live. We'll go up to here. Our red wires are. Black is the neutral. Oh, come on, you. And to some extent on here, we've got we've got one side that's going to the chamber heater and the bed. And then we'll have another group that comes in that is going to do, or actually, wait, this one's powering the chamber heater controller and the bed itself. So the heated bed itself. This side's going to be for um the chamber heaters, and on top of running the chamber heater, it's also going to power the main power supply. So that way we separate out the um the wiring and what's being powered by what some, so that makes it a little bit easier on our power systems, because you shouldn't necessarily run the bed and the chamber off uh the same power supply, and that's basically what we're going to be doing, is run or not paint the same circuit. So basically, if your chamber heater, which is mains, and your bed are heating up at the same time, pulling off the same cable, you could overheat that cable and start a fire. And we do not want that. So that's kind of why we're doing it this way, where we're running the bed and the heater controller, the chamber heater controller, off of one circuit, and then the other circuit's going to have the chamber heater and the power supply running off of it. So it distributes that power a lot better. Now the question here is, when we run this set of wires, just thinking through this in my head real fast. Because one of the things I might wish to do is um my head, one of the things that we may wish to is not use 5x5s here and use 3s and 3s if we can get away with it, and that way we'll leave the 5 counts for 24-volt side. Those would need the 2s. What are we going to do? Because this set right here would actually work fine on a 3x3 rather than a 5x5. And the other one, cable coming in, that's one, that's two, that goes down there as three. I can actually run these with 3x3s. So let me grab my threes. We'll switch these over to some smaller connectors since we're not going to need the large amount of possibilities there. The other thing that we can do, because we've got two ground wires coming in, is also join the two grounds together. That way we'll have all of our grounds isolated together. Less chance of any like ground loop interference that way. All right, wires, you in there. You in there. You. And we'll do our positive side or our line side. And like I said, I should be able to use 3 and 3. Pop this one off. So my plan and hope is to get this cabled to a point where we can kind of test out the tool, or not the tool head, but test out the electronics. Hey, Keeler's Way, how's it going? Keeler's Way, I apologize for missing your stream today. It's one thing when I'm streaming, it's another when I'm not, but we were actually down attending the grand opening of Echovate 3D. They're a 3D printing shop down here in Raleigh, North Carolina. And they were doing their grand opening of their new, larger store today. So me and Mrs. Dragon went down there and we were checking some things out there. Liz would have been happy with Mrs. Dragon. She was like rolling she was over there like selling the heck out of filament. It was funny because I think she went to make sure that I didn't come home with a new printer, which I didn't. But Yeah, I was ready to go, and she was still sitting there helping people. Positive, up. I got to remember I'm leaving wires for connection to the power supply. In fact, since we're using these wires, let me go ahead and, while it's easier and I got it, I'll trim this side up and do a whatchamacallit connector on it, fork connector on it, so that we can put it on the power supply. And that power supply, these are larger wires, so I'm going to have to use my blue fork connector. And yeah, Digital Dragon was put to work. Digital Dragon was talking the whole time. I know that's kind of crazy. It was almost like I was at a show or something. I was chatting so much with people. What am I looking for? Think through what I'm gonna been down here for. I need for these fork connectors. Oh, those were not. These are. All right, now I'm confused. Looking at. Yeah, these will work. Yeah, so I was definitely put to work. I was chatting up um a lot of people. There were two young kids there that definitely were, we were talking about different manufacturing techniques. One was doing robotic stuff and was asking about which type of filament's better for this part of the robots and stuff like that. We were talking about, you know, milling operations and I mean just about everything maker related. Um, and talking about this machine and the fact that it uses MGN 16 rails and ball screws. The one kid was like, "Oh, that's like a standard CNC." And I was like, "Exactly. That's exactly what it is." He was talking about wanting to get a Precision Matthews CNC and just all kinds of stuff. So definitely a fun day and fun conversation. What do I want to do that way? Um, Last one on here is going to be um that side. I'm going to hold off on that one just yet. We'll get this side done. But yeah, it was funny. Beverly, who is the owner, was about ready. Like, I think she might have referred to me as an employee at one point. She's like, "Yeah, Digital Dragon, Luke over there, he's an employee. He just doesn't know it yet." Like, "Oh yeah, I get you." About like my day job. But I hope your stream went well today, Keela. You didn't wind up strangling Jeremy by the end of it. All right, so this one is our neutral feed wire. There. I'm putting my power supply feed wires in the middle holes. The ones going to the chamber heater are going to go on the side. We're not going to use this particular wire, which is the wrong color, among other things. I do have a ground wire here that looks to be, might be a little short. See if we're coming like here on that direction. Dang it, it's going to be short. I was hoping to be able to use one of the ground wires segments I had left over. Let me see what I got in my 18 gauge kit over here. So, oh, how about them apples? We actually got some 18 gauge green wire. Now, granted, they're using some heavy gauge wire here. It is a 800-watt power supply, but it's still being fed mains voltage. Not like it's sucking down, you know, 200 amps here or anything. It's still, in fact, I could swap these feeder lines out with 18 gauge and we'd be fine, but I'm going to leave it that way. Fortunately, I don't have any like 16 or 14 gauge wire. Probably get some tomorrow, but apparently we just made plans and we're going to go to Charlotte tomorrow and do an IKEA run. What am I looking for? Oh, underneath the label maker, be all the fork terminals for the lower gauge. Yeah, we're going to be rolling to Micro Center and IKEA tomorrow. Evil Diesel wants to make a run out there, so we'll make a run. It's not gonna. It doesn't take much to twist my arm to go to Micro Center. Lucky you. Oh, yeah, maybe. The problem is, oh wait, I was going to say Mrs. Dragon was going to go with us, but she's already said she doesn't want to go. So, might be lucky me. I might be going over there with no adult supervision. Ah. All right, so that end was done. This end's going to be bare wire. I'm going to take off about 11 millimeters. Verify on your Wagos. The side of your Wagos has the measurement. We can take off a little bit more, which is nice. Always have something that you can measure by using the side of the Wago connector itself. So the power supply one is right in the middle. Boom, boom. That one's going to go over there. This one, this one, this one are going to be the line in. So the other power cord. I don't know why I did that one. Back out of the way. We've got one other connector to take off here and mount, and this is the neutral going out to the chamber heater. So the chamber heater, weird. So like the SSR, normally we're switching, whatchamacallit, we switch either live or neutral. In this case, we're switching live to neutral. Seems a little weird. There has been some sus wiring on here, which is why I've been really working to redo all the wiring on this printer. But I'm going to roll with it. This is the way the heater was done up before, so this is the way the heater will be done up on this one. Get the other power cable up here and get it fed back in through its cable gland. You just have to make that list first and stick to it. Oh yeah. Oh yeah. I agree with that statement. So we're going because Evil Diesel needs to update his computer, and I think he's going to go whole hog with memory and everything. New motherboard, processor, memory, the whole 9 yards. So if he's going to be doing that, then yeah, that's going to be a stick to the list, only to the list, don't go off of the list type of day. And then, you know me, I'll be like over looking at the 3D printer stuff, maybe some of the maker stuff. I might have to pick up some more Raspberry Pis because for whatever reason, I feel like I'm running low on Raspberry Pis. Uh, sure to verify your Wago connectors too. Make sure it's like anything else that you've got a good positive connection on that wire. Okay. There's one. This one's going to come in here and go here. Get it connected on there, and then we'll slide it down some. I should have paid attention to the wire routing. You go down, over the top. First. Oopsie. So, Keela, do you all have your Death Racer done and running around? Hey, Will Collin, welcome in. I remember, I know somebody did a video about their Death Racer. I just don't remember whom. Not sure if it was you guys or not. If it was you all, then definitely congratulations. I know that is a fun project to be done with. Well, because now you can start playing with it, right? See if we can get this one up on well. Okay. That means now I don't need the three-way, I can just use the two-ways, but I don't really want to go through and reprint these just to be two-ways. We'll leave them as three-ways, and we just won't populate the third way or the top one if I don't have to. One there, another one. Oh, there it is. And it's got stuff in it already. Awesome. This one out. Do like this, we'll be able to bring in wires from our hot end, be able to bring in our positive and ground from all of our runs into here. And open these up. And what I'll try and do is just look at ways of load balancing the connections between the two rails. Which once again means that we'll be cutting the ends off of those. Yay. Folks, I'm going to sit down. I've been up on my feet and my sciatic nerve is nerving. So I'm going to take a couple of minutes to sit down. While we work on wiring some more. Oh, what are we going to do? These over there. Need. That out of the way. Try and move this to me. More. Later. I need these two things. Closer. See it. Okay. I think this is where we're going to be primarily working now. Got all of our positive wires that need to come in. Grab our positive driver wires. Go ahead and cut these down a little bit. They don't as long. There's no need to have a ton of wire hanging out. Hey MG, how's it going? Welcome on in. We're working on wiring. We decided, made some command decisions here, and we've decided rather than use the terminal blocks that I got. So this is the terminal block size. This is the terminal block size that was in the case, and the ones that I ordered were slightly different, which means they don't fit on the pegs. I would need to have ones this exact size. So I'll hold on to these for some other project down the road. And we decided to go with all Wagos down here for our wiring. And now what I'm doing is I'm just bringing my cables through here, and I'm going to start wiring this stuff up one at a time. Put the positives, negatives in the back. So I'm just going to be trimming these down. We'd already gone through and put fork connectors with the intent of putting them on screw down terminals, but we'll go ahead and take those off and just run it with the Wagos, which may actually prove to be not a bad decision because we may make some changes later on to this. Again, this is a printer that came into Ecovate 3D, was donated to them. I'm just trying to help get it back up and in good running order. And right now, everything that I saw just screamed at me that it was not in a safe condition to operate. So I am doing my best to bring this into a safe operational mode. so that we don't hurt anybody trying to operate. So this is a Optimus P1. Um, these bags of crimp connectors, I buy them off of Amazon. In this case, these are Teamsic, Teansic, 500 piece AWG 22 to 18. These are number 8 crimp connectors. So number 8, number 6, those are the size of the screw down terminals. So these are number 8, so they would be for a number 8 screw down terminal. Now on these connectors that we're putting into the Wagos, right? I cannot put Wagos on the big 14, 16 gauge wires over here. They just will not fit in the Wago connectors if you put ferrules on them. Wagos are perfectly fine with bare wire because it's a clamping action on the wire. It is not a like a screw down clamp. It is an actual clamp. It's a bar clamp that goes across the width of the wire versus a screw down terminal, which can sometimes not be the best. Whoops. What I'm trying to do is get the actual screw down terminal out here because this particular wire feels not 100%. I can go through and put ferrules on both sides of these if I wanted to. I see all the time people use these particular screw down terminals without them. And the more I talk about it, the more I feel like I'm going to talk myself into. I'm not going to do it on these. These are signal wires. These are signal wires, but these are power wires. Let's at least put them on the power wires. The signal wires, not as critical of a connection, but the power wires, kind of a bit more critical. So we'll go ahead and put ferrules on those. Page on here. Well, there's writing on it. Kind of looks like Braille. Braille would not that way. Hieroglyphs. Let's go with that. Looks like hieroglyphs. Camera. Extra special eyes or really? What's 0.5 millimeter squared in American wire gauge? Anybody know off the top of their head? I can't remember. Looks like, feels like 20 gauge. Sounds good. Boom. Wow, now we only need to cut these down. That'll be cool to give us a more positive crimping action on that wire. A lot better. Great decision. Great decision, everybody. Appreciate you talking me into it. I know I say talk me into it. You guys more like guilt tripped me into it, but it's okay. I'll live with it. Or you like 3E but would like them cheaper? Yeah. I got those off Amazon. I tend to get those off of Amazon just because, well, why not? Um, I yes, going to something like, ooh, let me go to Mauser. Well, guess what? Mauser's not getting them necessarily, or Mauser, DigiKey, whatever. You know, they're not always getting stuff from. You know, they're buying stuff from Taiwan. Don't get it. They're buying stuff from Taiwan too. Read the listings. You'll see. Um, but it is what it is. These connectors, I really don't think there's going to be a huge difference between something made in Taiwan or something made in China and something made in Germany, other than the cost. I think quality wise, I haven't found one that's really crappy. I'll put it that way. Okay, so we just put a ferrule on this end, which means we're now going to need to just say, yep, let's do them right. Ferrules on all of them. Put in an order for ferrules. Two. Oh, there it is. Yeah, like this has Photech SSRs in them. I mean, I know a lot of people that wound up getting knockoffs when they went with Photech. So I'm not 100% sure if I really want to say, hey, let's keep these, or hey, let's possibly look at getting rid of these and getting something else down the way. Oh, yeah. I don't get them from Harbor Freight. Like, Harbor Freight is got to get them in a pinch. And Harbor Freight is me passing Lowe's and Tractor Supply. And I would be more apt to grab them from either one of those places. And it would be like, if one of those two places didn't have the right size, I may start by Harbor Freight and see if they have it. Okay, so those two are done. We've got this is the controller. Well, actually, let's see. This is the controller. This stuff is, what do we got here? We've got laser ground, hot end fan ground. We can swing through here and add the laser to this, especially since that connector just popped right off of it. Trim this a little bit. So the laser module, we're assuming this is the laser module, right? Because we know that this has a capability for a laser. Luckily, everybody's on board with not putting a laser on this, but it's an option. So we're going to go ahead and keep all the wires in place. These wires are just plumbing out to the top connectors here that go out to the printer. So it's just got bare ends on, or not bare ends, of course, but it's got unused pins at the other side. So that was laser, and then this is hot end fan ground. So we can cut that down some. Once again, this is the Optimus P1 Pro. This is a printer this is the electronics box for the printer that was donated to Ecovate 3D, which is a local 3D printing shop here in Raleigh, North Carolina. And they have graciously allowed me to come in and take a look at it. And I quickly said, oh dear God, please do not plug this into anything. And they said, okay. And I brought this home to start working on the wiring. So these two are coming from the business end. We've got the laser 24 volt, which bringing it that way, bring these. That's good. Laser, the fact that I brought those there and the other ones. But anyhow, sorry, I keep losing my train of thought here. They're allowing me to help get this back into working order. They want to see it print again. And of course, I want to see it print again because I want to use it to print things. So if I can get it to run, then I can print things with it. I've got some ideas on what kind of things I want to print. Okay, so we need the 24 volt laser. That's top connector here. So much off of this one. You'd wrap a wire around a screw. Well, and wrapping a wire around a screw is a valid connection method. It does work if done properly. The problem is too many people do it improperly and they don't, like there was a lot of bare wire wrapped around screws here. This is why I'm going through and doing what I'm doing. The problem being was I was like sitting here looking at wires and I just kind of went like this to move it out of the way to see the wire beneath it. And said wire came out of the SSR. And I was like, oof, duh. So that's what prompted part of this was just piss poor connections. And the need to, like I say, render this safe for people to use and get near, because this is going to be, we'll say, on the showroom. Like right now, it's right in the middle. It can't stay there because there's no power outlet near it. So it's going to have to move along one of the walls, but it attracts people, right? You see this thing that looks like a printer cabinet, or not a printer cabinet, but a like a network rack at a print shop, and you go over and people like are trying to look through the front windows and like, what is this? And I was like, do you want to see it? And I'll open it up and start talking to them about it. I do have a email into the company that makes this printer to see about getting like spec sheets and users guides, maybe slicer settings, simple thing. We'll see what that happens. Okay, so the left side here is pretty much the 4.8 amp drivers, which are these external drivers here for the Z-axis NEMA 23 stepper motors, the laser, and the hot end fan. On the other side, we'll leave one connection here to take it from a rail of the power supply. And then we'll do the other side, we'll bring in this is the main power to the controller board. Blue, by the way, is whatchamacallit, DC negative, because I'm not going to sit here and try and rewire some of this stuff. Gonna roll with it. And by rewire, I've obviously been rewiring. I mean, I'm not going to run all new wiring to all of this. I'm just going to use what we got and change where it makes sense. Like, oh, let's use a 20 gauge blue wire to connect mains ground to the 800 watt 24 volt power supply, and have that blue ground wire right next to the neutral blue wire. I'm fine to an extent, but don't be swapping color schemes for no apparent reason. And definitely don't do it on the mains power side, because that'll get people hurt. Well, I'm trying to get it closer to standards of at least, I would prefer all black and red, but you notice that a lot of my common wiring in here, these are standard aviation cables, and they're all black. And like if you get a Lineo wiring kit for your printer, chances are it's all black except for the main side, which is fine because they're labeled, right? That's why I'm going through and putting labels on here of, oh, this is MCU 24 volt. This one doesn't have a label. I'm probably, yeah, I'll leave it there. As long as I can get the thing over it, I am going to label this one. This is MCU to DC ground. But yeah, we actually had we had 24-volt connected straight to DC ground on some of these old bus bars, and it was scary. It was freaking me out. So this is MCU. Was good ground. Like I said, hopefully I can get this up and over that connector. If not, I'll just cut the connector off and we'll have plenty of room. And that's going to, there we go. So we do have that one labeled now as well. Now we've got front panel switch and the emergency switch. And tracking these back, my biggest fear was that this was mains, and it's not. This is 24 volt to the front panel switch and then emergency switch to 24 volts. So what this does is it will kill the 24 volt to the, oh, I see. This will kill the 24 volt coming through the, ah, oh, my colors are mixed up now. Alrighty. You want to watch me sort these on stream? It's great. It's like doing a screw sorting stream. Ay, ay, ay. This is going to be fun. Luckily, it was just primarily knocking a bunch of connectors one over and then spilling a bunch all over the table. So that'll be fun to clean up. Black, black, black. Black. We'll pull out the grays as we need them. Oh, hadn't cut the ends off that yet. Or I made my mess. Okay, so 24 volt panel switch definitely comes in here. So this is what brings 24 volt up to the switch on the front. And then we'll have another one that basically cuts 24 volt. And that's a disconnect switch. So that one may actually need to go back to the power supply. Let me think through that. So I need 24 power up to the switch, comes out of the switch, goes to the kill switch. The kill switch comes back to 24 volts and kills 24 volt rail or disconnects 24 volt. Let me think through that one a bit. So I think what I need there is 24 volt to front switch. Because this basically needs to be in the middle. This has to be turned on to even have power turned on. Then you pop this to add the circuit breaker. So this basically needs to feed power to the MCU and everything else. So this is 24 volt, this is 24. I'm just thinking through because if I plug 24 volt in to this side, it will keep all of this stuff energized and it doesn't mean jack or squat about this. Um, if I have MCU power, basically I need power from this needs to go in line between the board and everything else. So it's almost like I need another 3-pin connector that goes 24 volt to the panel switch. So we turn on power. This goes to a main rail here that adds power to everything that's here. Do I have anything bigger than a 5? That might be helpful. No. All I have is okay. Okay, I think I know what I can do. Um, I can jump these two together on positive and ground and make this basically one long bus bar. And then what we wind up doing is I'll need a 2 or 3 switch that I'll put up at the top. We'll bring 24 volt up to that, go into the panel switch, and then the emergency switch is what adds power back down into the lower rail. And it's the only thing that can add power back down into the lower rail. Otherwise, something's going to be energized regardless of whether or not the emergency stop switch is flipped. So, do I have, where's my freeway? Yes. Does that make sense to everybody? So the 24 volt that leads up to the front power switch, it'll go through the front power switch up to the e-stop switch. So you'll click on power and you'll have power, and then you'll unpop your emergency switch, and that power can now flow all the way through the circuit and feed everything down here. MCU 24 volt right there. These are the two going up to the front. So emergency switch 224 volt will go into this lower rail. We'll jumper these two rails together. This is basically the ingest power for the entire thing. Every once in a while, you just got to stop and think a little bit. Hey, Simberg, how's it going? How you doing? Hey, Chaos Drucker, welcome in. Rating with a party of 64. That is awesome, folks. I'm glad I just looked up and saw that. So we are working on rewiring this electronics cabinet. This is for a Feb top. So it's Feb top Optimus P1 Pro. This printer was given to the local, one of my local 3D printing shops, and I have, they let me know that it'd come in and that it could use some TLC. So I was like, hey, sure, I'll come take a look at it. And we have been trying to work on getting the wiring cleaned up. This whole area over here in this corner with the wiring was a hot mess. Kind of like this area right here is because I had my barrels sitting up here and I knocked them over. So I'm sure I've got a bunch over on the floor as well. Fun times. That's going to be a blast. What I'm trying to do is just think through the wiring, make sure I'm wiring this up appropriately, keeping the wires properly routed out of the way as much as possible, and making good solid connections. Unfortunately, a lot of the previous connections were bare wire to screw down terminals, whether that's on the motherboard of the printer or, heaven forbid, to terminal blocks for 24 volt and 110 volt for mains power. It was pretty scary all the way around. So we're working on getting that cleaned up, doing some proper wire routing. And I'm just having to think through right now the emergency switch. So we've got a power switch on the front panel and an e-stop switch. So we need to make sure that the e-stop switch is providing power down to, I'll say, the 24 volt rail here. and coming up from the power supply will come up to a 3-pin Wago, and we'll have the power supply coming in, power going to the front switch to turn things on, and then up through our kill switch and back down to the main rail. I guess I really only need like a 2-prong, but I'll leave a 3-prong on there in case I need to bring 24-volt always on power, like the fans or something. But yeah, I hope everybody's doing well today. Hope everybody is doing well today. Normally I stream in the mornings on Saturday. Today, because it was Evocate's grand opening and I went and attended that today with Mrs. Dragon, I came home, ate some dinner, took a little nap, and now we're up and running again. And I'm hoping that by the end of tonight, we'll have things wired back up. We'll do another look sanity check at it, and then we will maybe turn it on and see if we can at least get Marlin to come up. This is a Marlin based printer. See if we can get Marlin to come up. If we can get that to come up, then we're able to start looking and figuring some things out. What else do we have? This is mains going to our power supply, which is an 800-watt jobby that'll lay in here. I think that's everything, folks. Other than picking up all of my barrels. Oof. Bear with me a moment. I'm going to try and get as many of them as I can visually see right now, at least off the floor. I can deal with the rest of them later. Over on the desk, give me something to do after the stream tonight. Okay, Strucker, how was your stream tonight? What were you all working on this evening? This goes under here. There. Go over with that. We need to get our power supply in here, run a few more cables for power, which means I'm going to need 24-volt ground, a couple of more wires actually with ferrules, a couple of speed. What do we got? We got yellow, blue, red. With the blue for the ground and yellow for that. So pull these. Um, so Febtop is a Swedish company. Based in Stockholm. This printer, the Optimus P1 Pro, is an enclosed printer that is 600 by 600 by 1100 millimeters. So 60 by 60 by 100 or 110 centimeters. So pretty substantial size printer. Debating whether I'm going to keep these or maybe see if I can't clean them up and reuse them for something, or if I'm going to toss them. What'll happen is I'll keep them for a while and then I'll toss them. I mean, to be honest. I'm going to make little jumper pigtails out of this. Even that long, but I need to jumper the live wires between these two 5x Wago 221 415s. And once I get those ferruled and jumpered, then I'll be able to come back and do my power connectors in. And once again, we're going to bring ground up to our ground bar basically, and then the 24 volt will come up to this 3-pin, which runs through the front switch, through the e-stop kill switch, back down to power this positive rail. That's kind of what I'm doing, is making the little jumper to connect the 5x5 or the 1x5 rails, because I don't have anything bigger than a 5. Basically, if I had 6s, I could have used a single 6 on both of those. That pigtail, grab one of my blues and make a pigtail, or use a blue, or actually I got some black over here. We'll use a small piece of black, make a pigtail out of. That's fine. So that'll leave us with just one blue wire on the DC ground side, but that's fine. It's a previous run that came in the machine, and I'm not going to try and replace that huge run. couple more ferrules to bring in my 24-volt and ground into my little Wago bus bars here. It's in there. Good. Use the longer wires, and if I need to, I will cut them down to size. Grab a couple more of my gray ferrules. I have ferrules on one side and port connectors on the other. Ferrules, do port connectors on the other side. I don't know how much we'll trim these down. I'll go ahead and get them wired in because they're going to be closer to the back. And we'll cut these down to length once we get it in. Dang it, I don't know why I just did that. Guess I'll leaving these this size then. So I was going to do the port connectors, connect them in, and then do ferrules on the other side. That was great. Here. We'll go with it. We'll leave this long to enable us to be able to get the power supply in and out as we work on things. Enough. Over there. Port connectors. I buy my port connectors in bulk. Do most of my connectors in bulk. Start to get low, and I just place a big order. Get them by like 100 pack or whatever. Down slightly. But like I said, I hope everybody's having a great weekend. Staying out of trouble, staying safe, having fun. Hopefully starting to enjoy some good weather. We had some pretty decent weather today. Tomorrow it's supposed to rain, so I get to go and do some other fun type of things. It's gonna be positive. common. Then over here, we'd normally be using black and red. Red for our positive, black for our common or DC ground. Be fine using the yellow and blue that came in this, which was, I believe, the European standard. Or at least some part of European standard at one point. I know they, like everybody, we keep changing them around. This goes down here. These two will get out of the way because this needs to go in here. And what I want to look at, trying to figure out where they may have mounted this at based on the standoffs. And I see now where they were mounted at. I believe it was mounted using M4 screws. So we'll test that out because everything in here was pretty much M4 screws. Got some M4 screws here. Grab one real fast and try it out in the backside. Huh. I feel like they're M4s, but kind of not. Oh, they're M4. Now there's a spot where it looks like this might have mounted before. However, it also looks like we mount it there. Some of these wires may be a little bit more pinched than I would like, unless I move them around. So we can move those down some. Give ourselves some more playroom. There we go. Yes, there are M4 bolt provisions here for this. I just went with a shorter bolt, but I might do something similar to what I did on the SSRs, which was run a little bit longer bolt, a lock nut, or a locking washer, and a regular nut because I don't have any M4 lock nuts. I am screwing through the cabinet chassis, but I mean, these are pretty tight. I just want to make sure that we've got a good darn connection. And since I have locking washers and M4 nuts, might as well put them to good use. I'd rather make sure that I have really, really good positive connections on here than not. What just happened to that one? nut went on. There we go. Yes, I realize these are not the proper pliers or tools. I don't have the wrench on my 4mm wrenches out in the garage, so just tighten these down using needle nose pliers. That one's going to be good. This one I'll take back out and we'll put the longer screw in over here with a lock nut just to make sure that it doesn't go anywhere. Where am I at? It's quite possible I could have just used some Loctite and the shorter screws, but I prefer to do this. There is a provision for a third one down at the bottom, but one, I think those two are going to have it pretty good. And I'm not sure if I'm going to be able to get in there easily. Oh yeah, I should be able to get in there easily. Get this third one in there. Here to do with a ball end. Not over there. Where did I put it? Ball end driver. Where did you go? Interesting. Not over there. See right here. All right. We'll go without that one for the moment. We'll work on it in a minute. What I'm going to do though is grab that up. This will be my reminder that I need to do one more connection. Get this stuff out of the way. We need to tie these two into the DC, or actually, we need to tie those two into the DC. So once again, this is DC power that comes into the 3 Wago at the top. This is DC ground that will go into our ground. Nice and good and tight. Put those in out of the way. Now we've got our line, neutral, and ground. Ground is the lowest of the 3. Ground, neutral, or black. And our load or a red. Okay. There we go. And we really don't need to necessarily plug both of these cables in. We'll just plug the one in. The other one is just primarily going to be powering our heater electronics, which we don't need to have plugged in at this moment. But our trying to get the safety plastic put in there. Okay, that's in there. That's in there. These should be long enough that we can route them freely around the back. Get them plugged into our power supply so we can look for smoke. This, plug this, so there's nothing else in there but the printer electronics. Which is which. Okay, so that second one turned on the controller for the bed heater, or not the bed heater, but the chamber heater, and it's throwing an error, and that's to be expected. I'm not seeing and not smelling any smoke. I didn't see or hear anything pop. So what we've got at the moment, and I will set this up on its side here. There is our full electronics setup. Whoops. We've got our main board, all of our wiring that comes up to the top that goes out to the printer, our 800 watt 24 volt power supply, our SSRs. This wiring is a little bit snug, but it's okay. We got everything prettied up over here with our Wagos. Mains and mains, DC voltage here. We've got to be careful and remember I've got screw heads at the bottom of this. We bring this around like this. Okay, so we've got ease right here on our bed heater. That's because most likely there's no thermistor attached, so it's not getting a reading. That's most likely why we're getting the E. Our power switch is off. Power switch is turned on, but we don't have a screen or anything on the printer. That's because we're not providing 24 volt through to the rest of the printer yet. By letting go of this, just going to make sure and have an eye on it. We now have power to things in here. We got blinky lights going in here, right? Power and blinky lights. And we have control up here. So you've got laser, control, and print. We don't have a laser module attached to this, so no need for laser. We did go ahead and install or do the power, or we ran the connections as if we could add the laser module, but there is no laser module with this printer, which is good. I really don't want a laser module. Error, heating failed, system stopped, heater ID 0. So this is one of the other things is that right there is actually a good thing because there are 0 thermistors. There's no thermistor on the bed. There's no thermistor from the hot end. There's no thermistor for the chamber temp, right? The chamber is controlled by the lower controller, which is showing ease. So this is actually a good thing. I'm going to push the emergency stop. That clears all of the that cuts all the power to the 24 volt rail down here, because once again, the power comes up to the 3 Wagos. It goes to the front power switch. From the front power switch, it goes to the, so it'll come to the front power switch, which is in the on position, but there's nothing on the printer because we pushed the E-stop. You can turn that off to make extra special sure that there's no switch power coming through to this area. Now, what I'm going to do is find my basic thermistors, which I think are there. I keep a bundle of thermistors for this specific reason. These are standard 3950 basic thermistors, the standard glass bead thermistors. I don't even unbundle them. I know these are the, I think this is a separate thermistor if we were running a dual tool head. This is the one that goes out to the chamber heater, which I believe is not a standard thermistor, so I'm not even going to bother unplugging it. And I'll unplug that one. So, or I'm sorry, that's the bed thermistor. What the heck? We'll give it a shot. We'll unplug all three and we'll plug 3 of these in. And basically what we're going to do is see if we can keep from generating that error, which I believe all that error was saying I get no thermistor reading. So I think I'm heating and I'm not. So we're just going to plug 1, 2, and a third one in. Now, provided these are using standard thermistors, this should be close enough that we'll get a thermistor reading. Once again, we just pop the e-stop, lights start coming on. We've got our laser print control. We'll click on control. We see nozzles reading 26, beds reading 26. There we go. We've got thermistor readings, so we shouldn't get that error where it just shuts down. So beds reading 25, 27, 26, whatever, it's bouncing a little bit, that's fine. It's not the same thermistor, but it's close enough that we're at least going to get a reading of room temp, which is good. Bed heaters off, nozzle heaters off. I can tell it to heat it and see that it turns on a heater, but we're not connected to anything. So, but I can pull it for the nozzle here in a little bit. We've got motion, so this will be moving X, Y, and Z. We can move it in 0.1, 1, 10, and 50 millimeters. Extruder, low, medium, high speed. In and out, I'm assuming filament load, filament retract. There's an unload filament button. We are getting a nozzle temperature reading on here. Laser, once again, we don't have the laser plugged in. More. Connected, G-code input, setting, power off, end stops, and about. Settings. Interesting, it says Wi-Fi, printer firmware, build dimensions, temp preset, end stop setting, baud rate. I'm going to need to look through these. There's apparently 3 pages. I don't know. Here's the language page. Definitely want to stay in English. Is Delta? No. Stop. What am I doing? I don't know what I'm doing. Got into a page I'm not sure of, so I'm just going to bounce out. I don't want to change this config at all. What I want to try and do is figure out what the config is. I have zero knowledge of any of the configs on this. So that's really what I want to try and do, is figure out if I can pull any of the settings out of this. This is the Optimus 3D printers, the Optimus P1. Got their website, more instructions, support.optimum3d.com. Let's see if we actually get anything from that. Get this over. Hey Toby, 1029 or 10 or 100295, whatever. Hey Toby, welcome on in. Welcome on in. So we are playing around. This is a control box that we've been working to rewire. The wiring in here was a bit sketch. Let me kind of show you where we're at right now. We've got dual SSR setup. Whoops. This SSR is for the chamber heater. The other one is for the bed. So both of these are mains powered, running off 110. We've got two different 110 plugs coming in. One is driving just the chamber heater. The other is driving the bed and the 800 watt 24 volt power supply. The reason we have an 800 watt 24 volt power supply is that's running everything on the board, which includes these two large stepper drivers back here. These are, I have no idea what they are, like what model they are. I'm going to have to look it up and see if I can find the serial number online. But these are like stepper drivers that you would see in a CNC machine. They're currently set for 4.8 volts. And these drive NEMA 23 stepper motors that drive the Z-axis on 16 millimeter ball screw. Okay, so these are running at 4.8 amps. That's why we have such a big power supply. The other drivers, X, Y, and extruder are pretty basic, though we're running a 2208 in dumb mode for X, 2209 in dumb mode for Y, and the extruder is another completely different one that kind of looks like a DRV 8825. So don't know why. Nothing's running UART. This is a 8-bit MKS Gen 1.4 motherboard, or yeah, MCU motherboard. So this is running 8-bit Marlin. Right now I've got some I have thermistors plugged into all three thermistor ports just to give it temperature readings. Otherwise it auto shuts off. Okay, you met me at Echovate today. Okay, there you go, Toby. So this is the electronics for that big printer. And this is the first time that we've actually plugged power in because I finally redid all of the power stuff. And this was one of the semi undamaged terminal blocks. This had the 110 voltage in it. The other one was broken in two parts, and the replacement terminal blocks that I ordered were actually too long, so they won't fit on the mounting studs. So what I did was I just mounted a piece of DIN rail and started running Wago connectors. So I've got 3-pin or a set of 3 position Wagos for the 110 voltage, and then I've got 2 sets of 5 Wagos for 24 volt and ground, DC ground. They're jumpered together to make like one big bus bar. And then I've got a 3-pin down here that brings 24 volt in, and then 24 volt to the front power switch. From the power switch, it goes to the kill switch down to the 24 volt rail. That way you push the kill switch and it shuts all 24 volt off in the system. So we're all good. We're up. We see the screen. We've got connectivity. What was I getting ready to do? I don't know. There was something I was getting ready to do. The next thing that we can do that's going to be needed is we have to basically rebuild the hot end. And with the hot end, that gives me D&E. So I would be able to plug in the D&E cables, and we would be able to like test out the heater for the hot end and stuff like that. So that may be something we do next. But right now, I'm going to have to dig through this. I'll shut this off so we can work on the other piece. But I'll have to dig through the menus and see if I can pull the config out, or it does have a support web page on here. So we'll go to support.optima, whatever. Well, we're going to go to the support page. For those of you that are new following along, why does it have to be rebuilt? The wiring was atrocious. The every single wire into a screw terminal was bare wire. And I looked at a couple of components, like none of the SSRs weren't secured. The power supply was not secured to the chassis. One of the drivers was hanging not secured. One of the big DRV style or the CNC style drivers was not secured. I had like 4 wires that just came out, and one of them was like the SSR wire. And I'm talking the main side of the SSR, not the signal side. So I completely went through and put ferrules on everything, started put fork connectors. We changed away from doing the terminal blocks to Wagos, so we took off the fork connectors. We put ferrules on that as well. So basically, we were rendering the wiring safe. Oh yeah, Jedi Spidey, this thing is huge. So this kind of doesn't do it justice. Like, it shows 1 meter, but probably the closest thing is this picture right here, where you get to see the height. And I've got pictures that I posted and a little video today of me next to it. Yeah, it's like 6 foot tall cabinet. This thing is a beast, right? But what I want to try and do is, it does have a support dot Optimus 3DP.com. I want to see, yeah, the site can't be reached. Yeah, so that's the thing, is there's no support site that I can get to. I've tried to email them to see if I can get any information from them, and if not, we're gonna have to look, or not look, but we're gonna have to kind of spelunk a bit, see what we can pull out from the screen settings. Like, normally you're able on Marlin to go in and change something and save it. If so, we should be able to pull that information. Otherwise, we're kind of dead in the water, and just hope that nobody had been playing around with the Marlin settings and reflashing Marlin on this, right? Stop doing that, Luke. So I'm going to hit the E-stop, and that shuts off the 24-volt power. The fan on the power supply is still running. I'm going to go ahead and shut the power off on the front panel, which once again shuts off, disconnects 24 volt to everything, but the power going to the power supply is still on, so the power supply fan, of course, is still running. We'll unplug this, which completely renders it safe and inert. Everything should shut down. Thank you for shutting down. I don't have a side cover for this, so we're going to have to fabricate or print a side cover for this. And when I do, we're going to add like an intake fan and an exhaust fan to the electronics chamber. But for now, I can put that aside. I will pull my 3 thermistors. Easier said than done sometimes. Pull the 3 thermistors. And I'll replug in the thermistors in their slots. But I always keep a set of these just basic 3950 cheap thermistors. These are glass bead thermistors. I don't even take them out of the bundle, but that way I can plug them in and basically fake my way around um, the thermal runaway protection. Which the good thing is it did shut down, so that means it does have thermal runaway protection set up on it. When it couldn't detect the thermistors, it did shut down, so that was good. I need to straighten this stuff up real fast. Bear with me. Put this away. So I was going through trying to label everything that I could. That way we know kind of where everything's going. Yeah, they had like a blue wire for ground on the power supply right next to a blue wire for neutral to the power supply. And I'm like, that's scary because if anybody ever screws that up, that could be bad. They were mixing wire schemes as far as colors and stuff. And it was bad. Love the games you have? The games or the printers? Um, I don't have too many games. Game wise, I do have some. Actually, yeah, I do have a few games over there, but primarily a bunch of printers. Um, I know we were talking a little bit out at Ecovate. I've got about 30 different printers in and around the house here. A couple of them I'm pretty sure are going to make their way to Ecovate here in the near future. Some to sell, um, some just to have on display for them. So what I want to do is I'm going to pick this up and I'm going to set it over on the Trident. The Trident, we're waiting on parts. We need to get a new main board and a new or a beacon probe because the cartographer probe does not fit on the SLM printed toolhead that I've got. Oh, Satisfactory. Yes, I am playing Satisfactory occasionally with Evil Diesel and the crew out at KB3D. They have their own server. All right, here we go. So this is the tool head. For those of you that were there, I did show pictures, but I did clean this up. You can still see the remnants of the thermal runaway event that occurred on this. Now I am still waiting. I did order a new gear. I wonder, I mean, it very much looks like an Ender 3 gear, but I think all of my Ender 3 style extruders over here, oops, oh, forget that. I gave those away. That's right. I gave those to DB3D Dan. So I can put this together. I mean, this does look like it's been gnawed up some. I did order a couple of new gears. I also ordered the plastic parts for the extruder itself because the ones that are in here, well, there's some see-through parts to them, meaning the where the filament comes in has started wearing a groove right through the side. So I ordered 2 of these, and then when I was starting to work on a Keytech for a friend, I realized that the Keytech uses the same exact parts, the extruder parts. So I could technically, since I'm waiting for parts for that one, grab the extruder parts and use that to start rebuilding this tool head. I do have a metal set coming in from Funser through AliExpress. God only knows how long it's going to take, but that is coming in as well. We've got a wireless fan here, so I've got a replacement for that. The way this was set up, and Toby, you're going to love this. Let me make sure that I can. So the way this was set up, we had a 4010 fan. Your extruder and your heat break is right here. 4010 fan mounted like that with this spacer. So you've got 2 screws holding this fan into this spacer. The other 2 screws are now open. I had that right. To mount your blower fan on the front for your part cooling. And we were literally mounted like this. So I don't know about you, but the axial fan moves air from one side to another. So this was in essence creating a vacuum on the axial fan, which is going to prevent it from cooling much of anything. And that is probably why this fan is completely crunchy and it's not moving freely. It's not spinning like a fan should. So this basically burned up its bearing. We're going to replace this, and rather than using this, I'm going to figure out a way of doing standoffs and basically mount fan to fan with some type of standoff here between the 2 sets that are going to go right through here. And that way it can at least pull in air from 3 of the sides to feed the axial fan. Otherwise, we're just setting that up to self-destruct again. So yeah, that's kind of the plan. And okay, those are all, I'm good there. The other one that's got the mount for our BL Touch is a little bowed. This is a PTG print that was mounted right to the back here. So when we had whatever thermal event, it was warping this. So I've got to figure out if I can find this part anywhere and reprint it in ABS or PC. This is a 3D Touch, not a regular BL Touch. I don't know if the sensor works, but we'll be testing that out. Yes, the axial fan is cooling the heat break, and then the blower fan is a part cooling fan that basically mounts right there and just blows straight back at the nozzle. The original heater block, feeling this is an aluminum heater block. The thermistor, which is a new looking thermistor, somebody crimped that on right there, which has expanded it. This is stuck. I cannot pull this out. I cannot push it out gently. I'm going to have to percussively persuade that out. Or just set it aside and call it good. This is the original heat break that was in it. PTFE lined. So nice white PTFE. This is what the other side, the business end, looks like. Pretty crunchy. That opening is way off center. The nozzle that was in it is just as gunked up and bad. So what we're going to do when we go to rebuild this is use all new parts. We've got a nickel plated copper heat block that's good to 450 degrees. We've got a titanium all metal heat throat. It does, or a heat break. It does have a spot for minimal PTFE to go down in there, but it's not a full PTFE line all the way through. So we got a new heat break for it. This is a PT1000 thermistor that I want to try and see if we can't use. I don't think I can use this on the existing tool board, but this will be like stage 2 is taking the tool head back apart, swapping the thermistor in it for this one, and possibly swapping the 65-watt heater that I'm going to put in it for a or actually no, I'm going to put the 50-watt heater back into it. I'm just going to put some thermal grease on it because there was no thermal grease, which means it doesn't connect as well as it could. So I could put a 65-watt. I've got plenty of 65-watt heaters. I might even have a 100-watt that I can put in it at some point. But the goal is going to be able to put in some components that will allow us to run higher temp materials without batting an eye. That is going to be the overall plan. To keep things the way they are, because I can't play with the Marlin. These are standard NTC 100 thermistors here, so I'm just going to put a new thermistor in there. I'll re-terminate it in the appropriate JST connector. These are relatively inexpensive. This is a pack of like 10 of them. And great because there's no way of getting just one out very easily without causing a complete mess, most likely. But yeah, once again, the goal here was to render it safe because it's going to be in the Ecovate shop and I don't want it to hurt anybody. And the way it was, like I still need to add a chassis ground because there's no chassis ground in that enclosure yet. And I just remembered it as I was getting ready to say it's not safe because of no chassis ground, among other things. Yeah, there we go. We're trying to not make a mess. We're going to make a mess, and these are never going to go back in where they were. So just come to terms with that, and maybe we'll get them back in the bag, but they're not going to be the same as they were. We go back in. Probably not. No. All right. Fine. We'll just take these and set them over on the side for now. I'll add them to the bin. Hey, Ben. Ah. What I'll do is just try and gauge the same length. I'll redo the JST connector, pull these JSTs or this JST connector out and reuse it. Yeah, that's the plan, is to just rebuild the tool head to make it more reliable and add in the ability to easily increase like wattage and stuff like that on the components to be able to run higher temp materials when we're ready to go that route with this. Because a 600 by 1100 build volume just screams, give me some juice, give me some heat, and make me melt things fast. And we're going to do that. We're going to try and get a eventually we'll get like a 1.0 or 1.2 nozzle and just push her a bit and see what we can do. Okay, we got this. I'm going to use, I believe these are regular JST connectors. I'll double check before I crimp anything on here, but I believe this is just standard JST. Oh, those are a little bit bigger JST. But I looked. I might have to I don't have those. I'm gonna have to do I have some hmm. Don't have any right off the top of my head. I'm gonna have to order some JST connectors. Dang it. Hoping to be able to put this together tonight. But I am going to have to order some type of JST. I don't have this size and style of JST. I believe these to be. So I have to figure those out and get some ordered. Well, darn. Oh, oh wow. This is like last bead on a cartridge anyhow. Even better. Still need the JST. I just realized that this is the last bead style and not a cartridge. That's interesting. Okie dokie. Oh, I feel like 2 steps forward, 1 step back all the time. Side. And there was no heat sock on this, and I didn't even think about looking for volcano style heat. I'll order one of those as well. So we'll have a heat sock. And that way, when the blower is blowing, it's not going to start trying to cool this down because we want this hot. Oh, we want to be able to get this hot to push the um, our heat break to its limits. And then for right now, I've got a Batis 0.6. This is a hardened steel nozzle. 0.6 or 1.75 printer. I'm going to try and reach out to Fadis and see if I can't get um, a larger size donated for this project. That there. So I still need to look for the right connectors, but I'm actually going to be using a different style rather than a cartridge style. This particular block takes a bead style. Well, ducky darn. Bead style, a screw. You got to be careful when you screw these down in there that you just snug it, because if you put too much tension on the wires, you'll break the internal wire on your thermistor and it stops reading. Done that a time or two in my life. Sad days. Okay, well, darn it. I'm not going to be able to put this back together. I can do some stuff. Didn't fully like wash this down. I'll probably try and take some rubbing alcohol and wipe this down with a Q-tip and some rubbing alcohol. The two screws that I'm taking out right now actually mount it to the plate, and then this center lower screw here is a captive screw, and that's the set screw for the heat break. And you can get to that from the back side of the printer, so you can basically take the shroud off, loosen the heat break, drop the whole heat break and hot end, and disconnect the wires, and go work on the bench with this stuff. Why am I? Yes, I. 1 second. Three of those. And I'm just going to try and clean up some of the gunk that's on the hot end. Like I said, from the looks of it, there was a thermal event that occurred in this hot end. So just try and clean things up, make sure that we're good to go for getting this thing moving again. Get some of the gunk and unk that was in here. How's it going, 3D Medic Vents? Hope you're doing well today. I know this is a weird, strange time for a Dragon stream. We went and attended the Echovate 3D grand opening for their new store today. Nice. It was pretty fun. Met a lot of the owner's family. Oh, is that even? It's holding it on. Okay, so that's there. And once again, when I'm starting to look at the fans, once again, they had an axial fan in here using the spacer, so this kept the fan pretty close. The problem is they had the blower fan right in front of it, so there's really no airflow through here. This is the only place it could get air, and you had an axial fan sitting right in front of it. Put this in place, put this on there, and it's like that's the way it was set up. So there was no real airflow for this axial fan to suck air in to do anything. So what I'm going to do is get rid of this white piece, this printed white piece, and look at trying to figure out how much space I have here and use some spacers and just basically bolt the two fans together through this area. Because this, as you can see, this 24-volt fan is wireless. You know, it's doing the Bluetooth thing. Um, yeah. Now, because they've got these holes here, I don't know the size of these holes. I might be able to, um, I might have some standoffs that'll fit in there snugly. If not, maybe I'll print just some through standoffs that we can um, bolt through. That would be the best thing. I have to figure that out. Shouldn't be too hard. Figure out what size hole that is. I can just make some cylinders of the right distance and I just figure out that distance, make cylinders that size, use the cylinders as spacers, fan and two fans and run bolts through here with nuts. That'll be easy enough to do. But eyeball math. 9 millimeters. And what I'll do is I'll take my reamers and just use a reamer to figure out what size that is. Closest, unless it's some like half size. Make that one work. That was 8 millimeter. If I do an 8 millimeter by an 8 millimeter cylinder, 7 millimeters tall, print those out in ABS with a 3 millimeter hole right down the middle of them. Boom, done. I can make spacers and use those to space between those two fans. Not 8 millimeter round cylinder, 9 millimeters tall with a 3 millimeter hole in the center. Um, that'll be my spacer. Said that, and I'm going to forget it. Write it down. So we have the ability Um, bring up this. New. I'm just thinking, I probably don't even need to do it here. I can do it straight in the slicer. Call it good. Okay. I think what I'm going to do is go ahead and call a stream. I'm getting kind of tired, and I'm starting to ramble, and my brain's getting all kerfuddled on what I need to do next. So let me go ahead and call the stream. We will come back on Tuesday, or maybe I'll work on this off stream. Um, Actually, I will work on this off stream to try and figure out the spacers and stuff like that. Start figuring out what I need to order to be able to get our hot input back together. And when we come back the next time, either I will have it already built and down at Echovate, or we'll be finishing up putting the tool head back together when I'm at a point where I've got, brain cells working the way they should be working again. It's been kind of a long day. But thank you everybody for being here. Chaos Trucker and your crowd, thank you for the raid. I hope many of you stayed and we're having fun looking through this project here. If you have any questions, please go ahead and send me a thing on Discord. Hey, Evil Diesel, how's it going? Welcome in. So you missed it. The electronics case is all wired back up. We had it turned on. We're getting good stuff. Now we're starting to work on the tool head, and I realized that these are a different size JST than what I have. I believe they're JSTs. I do not believe those are a microfit. So I need to find these and get these on order. I also need to do a spacer, so I can do spacers through the 4 holes here versus the spacer that, the solid spacer that they had that was blowing the fan out, creating a vacuum. Yeah, and with that, like I said, I'm kind of done. Diesel, is little one coming to breakfast with us so that we can leave right after breakfast and roll? What's the Discord link? Right there. There you go. You can join the Discord. Yes? Okay, great. Awesome. Pretty darn sure that these were JST. I don't know. We'll look. I know. Yeah, we'll double check. We'll look. We'll get them done. But thanks everybody for being here. Like I said, I'm going to go rest, get some sleep, and we'll get back to this on the next stream. We'll either be looking at this, talking about it, or it will be down at Echovate, and we'll be talking about the next thing on the docket. But thanks all for being here. Thanks for everybody who came out to Echovate today and that I saw at Echovate. Jedi Spidey, Toby, it was great talking to you all. Ava the engineer, who was one of the kids I was talking to all day long. It was just great time chatting with everybody about this particular project and other projects that I've got going on. So have a great night, everybody. Let me see who I can raid out to if there's anybody even. Hey, that zombie hedgehog guy is on. Ah, Shenanigans. Looks like he's doing some CAD work in the background. Let's I think he's working on like one of his let's head over there. We're gonna head over to Shenanigans. Please come with me as we head over to Shenanigans. Yeah, have fun at Micro Center. Definitely, Jedi Spidey, definitely. But come on with me as we go over to Shenanigans. He's a little bit of a crazy tinkerer as well. He comes up with all kinds of new things. He likes to try out new turbine designs and set things on fire because he's printing them. Why not print things and light them on fire with kerosene? Because fun. Um, but thank you for being here. I'll see you guys on Tuesday, if not before. Have a great one, everybody. Bye now. And if you're watching this on YouTube, thank you for sticking around. I know some of my videos go fairly long, but you know this is just me as we're working through. So if you like the content that you see, please feel free to like and subscribe down below. Click that bell. Make sure you get notified of future videos when they pop up and become available. YouTube's going to be suggesting it. Thank you and